Okay, let's get to the practice of the elimination method. We're going to do some examples. Now, we know that in order to solve a system of linear equations like this one, the blue one and the red one, we want to find the x and the y that makes the left side and the right side equal to each other on both equations. And that's only going to happen right there on the point of intersection. So I did this example in my board, and I made a huge mistake. That's why you're seeing a screencast, and I'll show you. Even though it's embarrassing, I'll show you where I made my mistake. So let's look at this equation. So we have two equations, 2x minus 3y is equal to 7, and 2x plus 5y is equal to negative 1. First of all, I'm just going to make sure that I name them. Call this A and this B, so I know which ones I'm talking about. Something very nice is happening right here. I have both 2x and 2x, which means that if we follow the same technique we did in the previous video, and if I subtract or add this vertically, in this case I'm going to subtract it, right? Because if I do 2x minus 2x gives me 0x, so we just eliminated the x. If I say minus 3y minus plus 5y, that gives us minus 8y, and that was where I made my mistake, because I added them instead of subtracting them. And 7 minus minus 1, so 7 minus minus 1 actually gives us 8. And we can see right away very easily that if I divide both sides by negative 8, my y is going to be equal to negative 1. And I already have my y value. Now I need to find my x. So from here, I'm going to use, probably going to use equation A or B. I'm going to check A. Seems a little simpler. And I have that 2 times x minus 3 times y. Now I already know that y is minus 1. And therefore that equals 7. So if I just work things out, 2x minus, that's plus 3, is equal to 7. I take the 3 over to the other side, and 2x is equal to 7 minus 3, and that means that x is equal to, well, 7 minus 3 is 4, and 4 divided by 2, because that 2 divided both sides by 2, x is equal to 2. What I didn't do last time, and I'm going to do right now to make sure, is that check informally in my head if this works. So if x is 2, 2 times 2 is 4, and 3 times minus 1 is plus 1, so 4 plus 3 is equal to 7, check. 2 times 2 is 4, minus 5, 4 minus 5 is minus 1, check, and we got the right answer. Alright, so I need to state the final answer. So therefore, the point of intersection is, we go alphabetical, so it's x and y, 2, comma, minus 1. And that is our final answer. And now let me take you back to the actual video. In this example though, things are not as nice as on the other one, because I don't have, the x's are different and the y's are different. So I'm going to still call it A and B. I now need to decide if I'm going to get rid of the y or if I'm going to get rid of the x. Last time I could have gotten rid of the y too. I'll show you in a sec. Now it would probably be easier to get rid of the y, and I'll show you why. That was not intended. So if I multiply, I want to have the same number on top and on the bottom. So if I multiply this by 6, the top by 6, and I leave this alone, I'm going to have minus 6y and plus 6y, so I can add them vertically. In this case I will add them, not subtract them, and get rid of the y, eliminate it. So let's do that. I'm going to multiply this by 6, and I'm going to get 12x minus 6y is equal to minus 66. And here I'm going to multiply it by 1. I'm going to keep it exactly the same because I don't want to change it. So it's 5x plus 6y is equal to 15. And now, see, I have minus 6 and plus 6, so I'm going to add them vertically, and that's going to be 17x. That disappears, so it gets eliminated. And minus 66 plus 15, what would this be? Minus 10 is 56, 51. Is that right? I think so. So now divide both sides by 17. And let's see if this works. 51 divided by 17 is minus 3. There you go. Now I have the x. I need to find my y. Well, I'm just going to plug it back into one of the equations. The first one looks a little nicer, so I'm going to plug it back into a. And I'm going to have that 2 times minus 3 minus y is equal to negative 11. So that's minus 6 minus y is equal to minus 11 minus y is equal to minus 11 plus 6 minus y is equal to minus 5. Therefore, y is equal to positive 5. And we have that the point of intersection is minus 3 and 5. Okay, now again, we would do the informal check or the formal check with the two t-charts if it's required. But what would happen if I actually wanted to get rid of the x instead of the y? See, now I chose the y because it would have been easier. But what would I have done to get rid of the x? Well, probably I multiply this by 5 to make it to 10, and this by 2 to make it to 10 also, right? So I'm going to show you in the next slide how that would have worked out and how we get exactly the same answer. So this is the exact same equation. I'll just multiply the top by 5, so I get 10x minus 5y minus 55. And the bottom one, we'll multiply it by 2. So we get 10x plus 12y plus 30. And the only reason is so we can get this 10x and 10x. Now instead of adding like we did in the last one, I need to subtract so I can get rid of this. And when I subtract it vertically, I get minus 17y equals minus 85. So that gives me that y is equal to 5. And I follow, plug it back in, and I work out that x is equal to minus 3. Exactly the same thing as we got before. And one more time, the last answer, if it's algebraic, it's going to be the point of intersection is this. But if it's a word problem, we need to have a word answer.